the fact that these brackets are drawn the way they are in number 1. What does that mean? What's the base? All of it, top and bottom, yeah? So if all of that is top and bottom, if you're unsure of the way to approach this, I always say go with what you know, right? And what is the map you have to doing math? BEDMAS, right? BEDMAS says start with brackets, right? Well, there's brackets in there, isn't there? And all of you should notice something about that, and that, and that, those, and those. What is it? They're all the same bases, aren't they? So I can apply exponent laws inside this mess, yes? So let's do that. What's the base on the top? What's the number base on the top? 2. So on the top, I'm going to have 2, aren't I? Right? Because I got 2 times 2. So I got 2 squared, don't I? But we don't do that, do we? Right? So we got 2. And what are my letters? I got X and X. So what do I do with those? So it's X to the 5. And what do I do with Y squared and Y squared and Y? Y to the 5, right? Now, and what do I have on the bottom? I have X and Y to the 4th, yes? Okay. Is everybody cool with that? Yeah? Yeah? Okay. And I don't know where the 2 went. There we go. And this 2 is here, yes? Everyone's cool? Now this is all taken care of, isn't it? Is it taken care of, or can I do stuff up and down here? I can do stuff up and down, yeah? But I also have this squared situation happening here. Now, this is a bit of a problem. Why? What should be here? I drew it. What should be right there? 1. So this is 2 times 1 times 2, isn't it? Isn't that a different base than 2? So what do I need to do with these 2 2's that we didn't do? If I had this, 2 squared times 2 squared, the answer is 2 to the 4th, right? But I don't have 2 squared times 2 squared. I got another thing in there, don't I? So what is it? What do I really have to write in there? Can I leave that as a 2? Or do I have to do 2 times 2? What do you think? Some of you are saying do 2 times 2. So that leaves me with 4. Now, can I do stuff still in the brackets up and down? Can I? What's 4 divided by 2? 2. So I'm going to have 2. That takes care of these guys. What do I do right here? Yep, so what's 5? 5 minus 1 is X to the 4th, yes? And what do I do here? 5 minus 4, which is Y. And all of that is still squared, right? What does that 2 do when there's brackets here? Goes everywhere. So what's 2 squared? 4. X to the 8, Y to the 2. Right there. Now, please notice the point of this is to show you how simple you can make this from this, right? Once we did this step, it just falls into place, doesn't it? Okay, so mark your work. If you got D, give yourself a mark. So looking at number 2, where should I start? I see some brackets, right? And I see that 4 out there. So what does the top really look like? What does that 4 do to both of them? So I get X to the 8 and Y to the 4th. Now I notice Carlin is speaking, nobody else is. Does everybody else know why that works? That's exponent law 3. You've got it in your notes. Everyone should be cool with that, yes? Now on the bottom, I have 2 times 1, which is 2. What do I do with the x2 and the x4? Right? And I get x what, Daniel? 6. What do I do with y3 and y3? Add, and I get 6. Now I go up and down. Are there any numbers? There's 2, and there's no number written there, so it's a 1, right? So we know that 2 is living on the bottom still, which in a moment it will come up. There will be a red line there, and there will be a 2 below it.
I'll just imagine.
There it is. And what happens with these x's? Right, so what is it?
X2.
X squared. And what happens with these y's? Now this gets weird now, right? What happens when I subtract 6 from 4? I get a negative 2. Is that allowed? So right now I would have, and I'm going to just do a dotted line, I'd have y to the negative 2 up top, wouldn't I? Is that allowed? So where does it go? Down to the bottom. Oh, it's very hard to erase dots. I probably should have just written it. Y, and does it say negative?
No.
2. There's our answer. Why am I going over it this way? Because one of the mistakes you guys make, not you guys, but kids in general, is you don't go all the way through with one of the laws. Do you understand what I'm saying? You go like halfway through and then you jump to a new law. And then you jump to a new law, and then you jump to a new law, and you don't remember where you left off the first law. You picking up what I'm putting down? It doesn't matter what law you decide to start working with, but finish that off. Okay? All right, let's look at the next one. The next one, number 3, looks a lot like number 1, doesn't it? Right? Except it's the same thing under there, yeah? So, what should we do with the bottom here, or the inside the brackets? Or should we try this another way? Actually, let's do that. Let's use a different law in case people chose a different law to start with. Could I start out here? Which would mean that 4 would go where? To everything, right? So I'd have 2 to the 4th, x to the 12th, y to the 16th, times 2 to the 4th, x to the 4th, y to the 12th, all over x to the 12th, y to the 12th. Yes? Now, where should I go next? Top or bottom? Top? Okay, so what happens with those 2's? Are they both the same base now? So do I actually multiply 2 times 2? I add their exponents to get 2 to the 8th, yes? Okay. And what do I do with x12 and x4? Add them to get 16. And what do I do with 16 and 12? To get 28. On the bottom, x12, y12. And now all of a sudden, this is super easy to do, right? 2 to the 8th, you just get that off your calculator, 256. Or you can go 2 times 2 times 2 times 2 until you get up to 8. What do I do with 16 and 12? Subtract. What's 16 minus 12? X to the 4th. 28 minus 12? Y to the 16th. Right? And you can see how it doesn't matter what way we start, right? Just doesn't matter. Oh, yuck, negative exponents. This is where the wheels fall off for a lot of people. Now, what did I say back here? I said choose a law and finish that law off, yes? So, as soon as you see a negative exponent, most of you want to go get rid of them right away, yes? Right? But before you do that, let me ask you this. If I showed you this, x to the negative 2 to the negative 2, you see negative exponents there, don't you? And they freak you out, yes? But what do you do here? If this was x squared, you would just multiply over there, right? Well, what happens when I multiply over there? I get x to the positive 4, don't I? So it takes care of itself, yes? So when should we deal with negative exponents? at the very, very end when we've done everything else, right? So we're not going to deal with that negative exponent right now. Okay, so I am going to change the order because I'm not lazy, but I just like my x's first. And on the bottom here, where am I going to start? Because the bottom is a mess, isn't it? Where could you start? You could do that into everything, couldn't you? Could you also do that, tidy that up, and then put the 2 in? Would it matter? No, as long as you finish it off all the way through. So we're going to keep our x to the negative 1 because we don't know what's going to happen with it. And Daniel wanted to send this all the way through. So we're going to multiply that by what's 2 squared? 4 x to the 4 y to the negative 8 times x to the 8 and y to the 6. Now I still got brackets here, yes? So I should tidy that up first. So I'm keeping my x to the negative 2 because we're going to deal with them at the end. And what is this going to become? 4. And what's going to happen to the x's? Add to get 12. And what's negative 8 plus 6?
Negative 2.
X, sorry, not x. Y to the negative 2. Is everybody cool there? All right. Now, choose a new law and follow it up. I don't like this. It's yucky on the bottom, yeah? So let's deal with it. What's going to happen with the negative 1 and the 12? Because that's x and x, right? So what happens with the negative 1 and the 12? X to the 11. Nice, because negative 1 plus 12 is positive 11. Does anything happen to the y? No. Now, we're back to super easy. We just deal with up and down. What do I do with those x's? What's negative 2 minus 11? X to the negative 13. Because I'm already negative and I'm going further negative. Yes? Okay. And what's the exponent here really? 1. What's 1 minus 2?
Negative 1.
2 minuses, Daniel. 1 minus 2 is 1 plus 2, right?
Yeah.
So what is it? Y to the 3. And my 4 was already living down in the denominator, yes?
Yeah.
What there do I not like? I don't like the x to the negative 13. Where does the negative have to go?
From on bottom.
The negative exponent goes to... No. Because what if it's already on the bottom? That's the danger of saying, put it on the bottom. It reciprocates, right? So right now it's up in the numerator, so it's going to end up in the denominator. And there's our answer right there, D. Now please notice, again, all we're doing anywhere is multiplying or adding, right? It just looks messy, right? And 5. Anything to do with up top? So we're going to leave that alone. What could I do on the bottom? Anything you want. I would start with these guys out here, because there's nothing that can connect inside the brackets, is there? So what is this first one? Where does that 4 go? Into the brackets. So the 2 becomes 2 to the 4th. That's a big mistake everybody forgets. You forget that everybody remembers, 4 times 2 is 8. But they forget that the coefficient gets an exponent as well. X to the 8. And over here, I get x to the, what's negative 3 times 2? Negative 6. And what's negative 1 times negative 3? Positive 3. Now I can sort out, I still have nothing to do up top, but on the bottom I got x to the 8th and x to the negative 6. What's that? 2. And the y's are staying the same. Now, can I sort out here? Are there any negative exponents? They all took care of themselves, didn't they? So nothing's moving. What happens when I have the same thing on the top and the same thing on the bottom? They cancel. Now, this is another mistake every kid makes. You think when you cancel, it disappears. Does it? No. That is the number 1, right? So because if I put 0 up there, this is going to be nothing, isn't it? Yeah. And it's obviously not nothing. So I got a 1 there. The y's are gone. What's the only thing I can do down here? I know what 2 to the 4th is, right? I don't know what x squared is because I don't know what x is. But I know that 2 to the 4th is 16. D. Now, the reason I gave you this is because it's a quiz, it's not hurting you, yes? Yeah. But it's to show you that those 7 rules that you guys did 2 pages on that was pretty easy still apply here, even though they're bigger questions. Okay? Everybody cool? All right, so far you're out of 5. Now, this was the stuff we just did yesterday, Tuesday. So if you didn't do okay on it, that's really all right. The only reason I gave you this quiz is because I knew I wasn't going to be here, right? And I didn't want the sub to have to try and teach something, okay? So if you didn't do okay on these, that's all right. But I would have liked to have seen you make some progress, yes? Because I gave you 3 methods to do this, and we did practice it a bit. 28 is, I'm just going to do the quickest method, the one I use, with perfect squares. This is 4 times 7, isn't it? What's the square root of 4?
2.
So what comes out? 2, and what stayed under there? 7. Everybody cool? Now, if you don't remember that rule, you did this. 28, 7, 4, 2, 2, and there was your group of 2. Right? 50. What's 50? 25 times 2. Why'd you choose 25, Rihanna? Because 25 has a square root, right? What's the square root of 25? 5. What did I leave under there? 2. Now let's get the 72 was one that we actually did in our notes, right? If you can think of a perfect square that goes into 72, you should use that. But it's a big number. You guys don't know your 36 times table. So most of you probably broke it down into 9 and 8. And then you might have broken that down. You stopped at 9 because 9 is a perfect square. Then you maybe broke that down into 4 and 2. And you stopped at 4 because 4 is a perfect square. What's the square root of 9? 3. So what comes out? 3. What's the square root of 4? So what comes out? 2. What did I leave under there? A single 2. What do all the numbers in front of a radical do? Multiply. So what's that? 6 root 2. Cool? Okay. Now remember, everything's worth 1 mark. So if you did some factoring, give yourself a half mark. Okay, now this one's a mess, right? It's a giant number, and you probably don't know some squares that go into it. So how do you start? By factoring. It ends in 2. So what can I divide it by? 2 and 256. Why can I stop there? Because 256 has a square root if you've memorized your list, right? What is it? 16. Right! It's 16. What's the square root of 256? 16. What did I leave under there? 2. But what was already out in front? What do all the numbers out in front do? Multiply. So there was already a 6 living there. So now I got a 16 and a 6. So what do I do with them? I multiply them to get 96 root 2. Right? Okay. 10 looks weird. What's weird about 10? It's a negative out in front. But it's still just a number, right? Still just that. So I got to deal with this in here. 252 ends in 2. So what can I divide it by? 2. to get 126, yes? Stop there because it's a prime number. Does 126 divide by 2? Ends in 6. Does it divide by 2? Yep. And 63. 63 divides by... I would do 9 and 7. Why would I do 9 and 7? Because 9's a perfect square, isn't it? So is there a group of 2? So what comes out? 2. Does that have a square root? What comes out? What's the square root of 9, Jordan? 3. What was already out there? Negative 7. And what did we leave under there?
7.
Just the 7. What's 7 times 2? 14 times 3? 42. You're going to use your calculator. And a negative out front. Negative 42 root 7. This one we already know because it was number 1. It's 4 times 7, right? What's the square root of 4?
2.
So what comes out?
2.
2. What was already out there?
3. Negative 3.
So it's negative 6 root 7.
Yeah.
Now we get to what I never even showed you. Because it's the next logical step, isn't it?
Yeah.
If there were no exponents there, what would you do? You'd break down 448, right? So let's break down 448. What's the first one that you're going to start with? You're going to divide by 2 because it's even, right? 2 and 2, 24. Yeah?
Yeah.
Still even. 2 and 1, 12. Still even. 2 and 56. Still even. 2 and 28. Oh! 28's one that we've dealt with. So we're going to stop right there and go 4 and 7. Yes? Is there a group of 2? So what comes out? I already had negative 3 out there. Now there's a 2. Is there a group of 2? So what comes out? Another 2. That's not a group of 2, but it has a square root. What is it? So what comes out? 2. Excellent. Leaving what under there? 7. Now you guys are smart kids. U to the third. This is why I do exponents first. What is u to the third? It's u, isn't it? What's that? It's a group of 2, isn't it? So what comes out?
U squared.
Not u squared,
U cubed. No.
just u.
Oh.
Because just like we didn't take out 2 squared, we took out 2.
Yeah.
So what comes out? U. What stayed under there? U. What's v squared really?
VV.
VV. Is that a group of 2? So what comes out?
V.
V. Anything left under there? So what's 2 times 2 times 2?
6.
2 times 2 times 2.
8.
8 times 3. 24 with the negative. Negative 24. And everything out in front multiplies, right? Because if it happens once in math, it always happens in math. So if there's numbers out in front, they multiply. So if there's letters out in front, what do? Multiply. How do we write letters and multiply? We just write them. UV. And what did I leave under there? 7U. Right?
Yeah.
Now, I never showed you that, but as soon as you see it right now, if you didn't attempt it, you should be going, that makes sense. Right? All right, so we're going to do the same thing over here, yeah?
Yeah.
So, 108. Break it down. Most of you are going to go 2 and 54, right? Then most of you are going to go 9 and 6. You're going to stop at 9. Why? Perfect square. Can't stop at 6 because it's not a perfect square and it gets smaller. What's it going to become?
3 and
2 and 3, right? Now, what do you see right there and there?
2. 2.
It's a group of 2, yeah? So what comes out?
2.
2. I already had a 6. Now I got a 2. What comes out here? As soon as it unfreezes. Why did I stop at 9? Because it's got a perfect square, yeah? What is it?
3.
3. So what comes out?
3.
3. Look at how brilliant you guys are. 3. What about U? How many U's are under there? 1. Can I get a group of 2 U's out? Nope. So what number did I leave under there? I left a 3, right? And I can't touch that U. But I got how many V's? 2 groups of V's. So I can take out 1 V. That'll cover 2 of them. And a second V. That'll cover 2 of them. So I end up with 6 times 2 times 3 times V. V times V, which is V squared, right? So 6 times 2 is 12. 12 times 3 is 36 V squared root 3U. Everybody cool? Now notice there is a bit of a shortcut here. What little number should be right there? 2. I took out a V squared, right? I had V4. Do 4, 2, and 2 share a relationship? 2 times 2 is 4, and 4 divided by 2 is 2, right? What little number should be right there? 2. 3 divided by 2 is 1U with 1U left over, wasn't it? V2, 2 divided by 2 is 1V. Any remainder? Everyone see that little trick? Do you have to use it? No, because as long as you know that's V, 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 and you know you're looking for groups of 2, you're in business. Everybody cool? Okay. So give yourself a mark out of 13, and remember, it's... Was there one more?
Yeah. There's one all.
Oh, what a dummy head. All right. Well, what do? We already did 108, didn't we? What came out? The 2, the 3, and we left a 3, right? So what's out in front? 4. And then what else? 4, then 2, then 3. How many U's are coming out of there? 2. How many V's? 2. What did I leave under there? Just the 3. 4 times 2 is 8. 8 times 3 is 24. 24 U squared V squared root 3. So give yourself a mark out of 14, and I'll get that from you later because it's a short day. I don't want to spend time on it. Okay? Now, if you didn't do super hot, does it matter? No. But now that you've seen it, and it's there on the video, what should you do before your actual test on this unit? Make sure you go back and watch this. Because as we were going over this, almost all of you are like, oh yeah, that makes sense. Right? Okay. If you could all open to page 101 in your books, that would be lovely. Because like I say, you already know how to do what we're going to do today. But first, we have to take a trip back in time. Okay. When you first arrived in kindergarten, the first math you did was exactly, right? But it wasn't even numbers, was it? It was Rihanna has a cookie, Eden has a cookie. How many cookies do they have? And you went, 2, Mrs. Bad Crumble, and you all got your gold stars. And then Mrs. Bad Crumble went hardcore. She said, what if Carlin sits down with Eden and Rihanna, and Carlin has 2 cookies? Then you went, okay, 1, 2, 3, 4, Rihanna, Eden, 4, Mrs. Bad Crumble. And Mrs. Bad Crumble said, oh, you are a math genius. You should work in rocket science. And she gave you a second gold star. And then it took 2 years to figure out adding and subtracting, yes? Because it wasn't until grade 2 that Mrs. Bad Crumble said, what if everyone in the class had 2 cookies? And then you ran out of fingers, didn't you? Because you couldn't count, right? So they taught you multiplying, right? So you started with 1 plus 1. That took a year, kindergarten, to figure out adding. Then they went hardcore and they did bigger numbers. That was grade 1. And then in grade 2, they went really crazy and they showed you 2 plus 2 plus 2 is really 2 times 3. But they didn't show you the dot for times until what, grade 7? Last. Okay. All right. And then I used to have a button that said this. And then the devil showed up because all of a sudden math got the alphabet. Right?
I learned that in grade 6.
So along came 3x. And what did that mean? It meant 3 times x, yes? Okay. Then in grade 9, or possibly 8, along came this. 2 times 3x. And then everyone's like, okay, what's that? Right, so this became 6x, yes? And then along came grade 10, and it became 2x times 3x. And what did you do? Numbers went with numbers. Exponents went with exponents. And you got 6x squared. Yes? Right? Now the next logical step was, go back over to here, 2x times 3y. What did you get there? 6 xy. And that is right now where you all live, mathematically speaking, with multiplication, yes?
Come a long way.
You have come a long way. When you think about it, you really have, haven't you?
Yeah. I'm pretty
Right? Because if you showed this to the kindergarten kid that was on cookies, trying to do the adding without eating the cookies, you've come a long way. So, the last thing you learned was a new way to express numbers, right? And that new way to express numbers came from real numbers, integers, and everything. And you just learned this move, 48. Because you know that's a number, yes? But it's an irrational number. So you learned how to deal with it, right? And when you dealt with it, you broke that down and you ended up with 4 root 3, yes? Now look closely at that. It's no accident that I ended up right here. Do those share a similar construction? There's a coefficient. In this case it's 3, in this case it's 4. And what do coefficients do? They multiply the next thing, yes? So this is 3 times x, this is 4 times root 3, yes? Everybody cool? All right. Now, then we got to here. And we saw that coefficients go with coefficients, right? And then we got to here, and then we saw variables go with variables. And then we got to here, and we saw that sometimes those variables don't even mix, right? So what is the logical assumption for you to make if I gave you this? 4 root 3 times 2 root 2. Without being taught, knowing everything you know, which is to here, what logically is this answer? What are you going to do with the coefficients? 8. And what did you do with the multiplicand? Not the multiplier. What did you do with the multiplicand here? You just multiplied it together, right? So what do you think we do here? Multiply it together. So this becomes the root of 2 times 3, which is 8 root 6. Is everybody good? And you didn't need me to show you that, did you? If this was an 80-minute day, what would I have done right here? I would have said, everybody stop and talk to their neighbor, yes? And you would have figured it out. Some of you would have been astute and read these instructions right down here, if my computer was thawed. But there are some rules that we need to follow, okay? One of those rules is this. Multiplying radicals can only occur if both radicals have the same index. What's the index? It's that little number right there. Okay? So this works. That is okay, because they're both x. But does this work? No. Is everybody cool with that? Now, just like everything else we've ever learned in math, do all of our other rules, does all of this get thrown out the window when we get to something new? No. We have to remember everything. Hey, Mr. Shipper.
I brought you a Canadian stress ball.
Oh, thanks, buddy. I don't know why I'm so relaxed and even-keeled.
I like the face fungus. It looks great.
It does look great. It makes me very distinguished.
Yes, I can't grow because I can't grow hair here, so I look like a chipmunk.
Oh, that's the
I
worst.
look like Bucky Beaver.
It took me a long time for that to come together.
Canadian ball.
Thanks, Mr. Shippets. Now I'm going to bounce it.
Yes. Multiplying radicals.
We are indeed. It's radical.
Radical.
It's almost like Mr. Shippets and I went to the same school of punning.
Ooh, I like that. Guys, never trust an atom. They make up everything.
See? Punning. They make up everything.
They make up everything.
When do science teachers tell jokes? Periodically. Yeah. No, I didn't. It's just funny. Because of the periodic table of the elements. All right. So, all of our rules apply. Everything we've ever done in math applies, yes? So let's apply our new thing here. What do I do with negative 7 and 5? Multiply them. What do I get? Negative 35. What do I do with 3 and 8? Multiply. So I get root what? 24. Have I done my multiplication? Yes. Do I have an answer? Yes. Would that answer satisfy Mrs. Bad Crumble and get your gold star? Do you think? It might get a silver star. It wouldn't get the gold star because of what we learned on Tuesday. Because on Tuesday, what would we do with that? We would break it down into what? What are the factors of 24? You could use 3 and 8, but I wouldn't use 3 and 8. I would use 4 and 6. Why? Why is 4 a good one to use? Because it's got a perfect square. What is the square root of 4? 2. So what comes out here? 2. What do all coefficients do? Multiply. So what do I get? What's 2 times 35? 70. With a negative. And what did I leave under there? 6. Does everybody see? It's nothing new, is it? It's actually exactly what you were taught in the 9th grade here, isn't it? Except instead of an x, we have a square root. Right? So let's look at this one. What do I do with the coefficients? Multiply them. But I have no coefficient there. Is it 0? It's 1. So what's 1 times 3? 3. What do I do under there? What's 2 times 8? That equals 3 root 16. Hey, wait a minute. Root 16. I know something about root 16. What is it?
8. Well, 4. Yeah, 4. That's 4.
So what comes out?
4.
4. Did I leave anything under there? No. So what's my answer? What does everything out in front do?
Multiply.
12. Root. I left nothing.
Yeah.
Right? 12 root 1, isn't it? And the root of 1 is 1, and 12 times 1 is? 12. So I'm done. Way to go. All right. Now we're going to get a little Funke. Funke. Have a look at this question. What do I do with the negative 8 and the 6? Multiplied. Easy peasy. What is it? Negative 48. Yeah? Now, what do I do with the 6 and the 12? 6 times 12. Yes? Now, you guys are smart kids. You know 6 times 12 is 72, yes? But you know that once I multiply 6 and 12, 72, I'm just going to have to break it down again, aren't I? Well, here I have it already started to be broken down. So what can I do? Break it down more. That's 2 and 3, right? And that is 3 and 4, yes? Everyone agree? Okay. Why did I use 3 and 4 instead of 6 and 2? 4 has a perfect square, right? So, what do you see there? Is that a group of 2?
Yeah.
So what comes out? A 3. Does that have a square root? So what comes out? A 2. What was already out there? 48. What did I leave under there? 2. 3 times 2 is 6. 6 times 48 is 288 root 2. But what did I not remember yet? That negative sign. Is everybody with me?
Yes.
Okay. Now you're going to learn something, another new thing. Well, it's not new. It's just common sense. What do I do with the exponent, or the coefficients? So what are they? 3 and 1, so it's 3. What do I do with the radicands? Multiply them to get 3 times 3, right?
Yep.
You guys are smart kids. Isn't that a group of 2?
Yeah.
So what happens? What happens to that group of 2? What comes out? A 3. What was already out there?
3.
So what do we get? 9. Now I want to show you guys something. You're smart kids. What did you notice about those 2 radicands?
They're both 3.
They're both 3. And when we multiplied them together, we got 3, didn't we?
Yeah.
So what does that tell us about the square root of x times the square root of x? That answer is x, isn't it? Right? And that makes sense. Because the square root of 4 times the square root of 4 is 2 times 2, which is 4. Square root of 4 times the square root of 4 equals 4, because that is 2 times 2. That equals 4. If this equals 4 and this equals 4, then this must equal this. Everybody cool? All right, so now, Mr. Myers. Are you allowed to forget anything you learned in math ever? No. If I gave you this question, 3x times 2y plus 6, could you do it? What would it be? Don't write it down, just look at it. It would be 2 times 3, which is 6. So it would be 6xy plus, what's 3 times 6? 18, then what? X. You know that from grade 9, distributive property, right?
Yeah.
Do you think it applies here? Is it math? Does all math apply all the time? So what am I doing here? I'm doing that. This first one, and I'll draw it with a red arrow, goes here. What do I do with the coefficients? Multiply. So what do I get? 15 root. What do I do with the radicands? Multiply. So what do I get? 16. Everybody cool? Okay. I'm going to erase that. Now I'm going to use a blue arrow. Now I go here. What do I do with the coefficients? Multiply. So what's 5 times 2? 10. What do I do with the radicands? Multiply. So what do I get? Root 24. Is everybody still cool? Okay. And change color again. Work in green. Now I go here. What do I do with the coefficients? Multiply. So what is it? Minus 5. And what do I do with the radicands? Multiply to get what? Root 40. Gold star or silver star?
Gold.
Silver.
Why silver? Because it's not simplified, is it? What is the square root of 16?
4.
4 times 4, yeah? So what comes out?
4.
4. What's 4 times 15?
60.
60. Plus, what is, does 24 break down? We've already done it on this page, haven't we? 6 and 4. What's the square root of 4, Josh? 2. So what comes out? 2. What's already out there? 10. So what do I do with 2 and 10? Multiply to get 20 root 6. Yes?
Yep.
Okay, smart kids. What's 40 break down into? Think of perfect squares that would go into 40. 4. 4 times 10, yes? What's the square root of 4?
2.
So what comes out?
2.
2. What was already out there?
5. Negative 5.
So it's minus 10 root.
Yep.
What did I leave under there?
40. No 10.
10. Done. Everybody cool?
Yep.
All right. Now, we have to turn on our logic brains now. If you have been just learning steps, look at this next question. There's no coefficients, right? So this next question says, I got to put the radicand with the radicand, yes? And according to everything we've done, we should multiply those, yes? 16 times 54 equals 864. Do you want to simplify that? No, it's a giant number, yes? So what can we do over here to make it easier? Simplify first, right? Now these are cube roots, yes? So I don't want to use squares, I want to use cubes. Is there a cube that goes into 16? Think of the cubes. 1, 8, 27. Does one of those numbers go into 16? 8. That's 8 times 2, isn't it? What is the cube root of 8? 2. So what comes out? 2. What did I leave under there? 2. Everybody cool? 54. 1, 3, 1, 8, 27, 64. Well, it can't be 64 because I only have 54. Does 27 go into 54?
Yeah.
How many times? Twice. So that's 27 times 2, isn't it? What's the cube root of 27? You don't need your calculator, you got it memorized.
I don't.
1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So what's the cube root of 27? 3. So what comes out?
3.
3. What stayed under there?
2.
2. Holy. What do I do with the coefficients? Multiply them. What do I get? A number.
Sorry, I was writing it with one to answer.
What do I get when I do 2 and 3?
6.
6. Cube root. What did I leave under there?
2.
2 2's. 2 and 2, which is
4.
4. Now, some of you are going to make a mistake. You're going to say, oh, Myers, You just told me that when it's root and root, it equals 2. Right? You just showed me that right there, guy. Right? Why is this not the case? I need groups of 3, don't I? 2 times 2 is only a group of 2. Picking up what I'm putting down?
I get that now.
All right, now, look at G. If you've only been following steps, you automatically are going to go 28 times 63, right? Which is 1,764. Do you want to break that down? I don't, so what should we do? Simplify. What is 28 really? 4 and 7. What is 63 really?
3, no.
Bigger. 9 and 7. Does 4 have a square root? What is it? So what comes out? 2. What was already out there? So what do we get? 10 root what? 7 times. What's square root of 9? 3. So what comes out? 3. What was already out there? So what do we get? 9 root, what did I leave under there? 7. Now, what do I do with the coefficients? What's 10 times 9? 90. And now, does what I just show you work?
Yes.
What's root 7 times root 7? 7. It's the root of 49, which is 7. So this is 90 times the square root of 49, which is 7. So this is 90 times 7, which is... He waited patiently. 630. Does everybody see how to do it?
Yep.
It's pretty easy, right? Right? Now, I'm going to go to one newer thing that isn't part of grade 10. I just want to see. What do you think would happen if I had the root of 20x squared times the root of 6x cubed? What would that be? Can I forget any of my other math? No. So what do I do with the coefficients? Multiply. 1 times 1 is 1. So we don't care about that. What do I do with the radicands? What do I do with 20 and 6? Multiply to get what? 120. What do I do with the rest of the radicand? Multiply. So what do I get? X to the what? 6th?
No. 5. X to the 5.
X to the 5th. Why 5th?
Because you had them.
Because we remember our exponent laws that we're not allowed to forget, and we apply them here. Now, could we simplify that? Sure we can, right? That is 4 times 30, right? And 30 is 6 times 5, right? No pairs.
Yeah.
So what's the square root of 30? Square root of 4.
2.
So what comes out?
2.
2. What stayed under there?
30.
30. How many groups of...
X is 5.
How many groups can we get out?
2.
2. So I'm going to bring out 2 x's, yes?
Yes.
X squared. What did I leave under there? 1x. Because this is really x, right? There's one group. There's a second group. I left 1. How would I write this in proper math form, the way math guys like to see it? 2x squared root 30x. That, ladies and gentlemen, is your pre-calc 11 multiplying. That's it. Well, you'll need it in foundations too, big stuff. So because I care so much about you, my Grinchy heart, 2 sizes too big, I have given you your grade 11 math already. Even though it really isn't grade 11 math, is it? It's what you already knew, really technically from grade 9, isn't it? All right, I'm going to shut up my face. And you know what? You guys worked so hard, don't do anything tonight. Tomorrow's Friday.
Tomorrow's Friday?
Yep. Don't do anything. We'll have a work day. Listen to me! We will have a work day in class tomorrow. Okay, because I missed a day. You guys did work hard today. You learned a lot of stuff. I'm actually really happy with you. And we got a test marked. I'm very pleased today. So, hey, though, I do want to record that quiz mark. I could do it right now, then nobody has to remember. I'll just come around and do it privately so you don't have to say out loud what you got. Even though you're all going to tell each other anyway. Just let me put it in. What was it out of? 14?